What's up guys, it's Simon Fiaz and today's video is on AQA A-Level Chemistry Paper 1 2017. Official A-Level paper. Now there are going to be some questions which I can't do because I haven't gone through the content. It's only February, 1st February recording this video, and for those questions I'll come back to it once I've gone through the content. So let's go for question 1, which I have gone through the content. Define the term entropy of lattice formation for 2 marks. So entropy lattice of formation. Enthalpy change when 1 mole of solid ionic compound is formed from its gaseous. And for this question, just learn your definitions. There's not much to it, and if you haven't learned your definitions, then come back to it to the end. 1.2. Some enthalpy change data shown in table 1. Use the data to calculate enthalpy of lattice formation of silver iodide. Enthalpy of lattice formation, so enthalpy of products minus reactants. And I can see that it's going to be products. Obviously, in this case, you draw out a cycle and all that. What I can see is going to be minus 464 plus minus 293 minus enthalpy of reactants minus 112. And I get minus 869. Calculation of the enthalpy of lattice formation of silver iodide based on the perfect ionic model gives a smaller numerical value than the value calculated in question 1.2. Explain this difference. So, perfect ionic model. Well, the first thing for these type of questions about perfect ionic model and all that, you can always get your first mark generally by just saying silver iodide, in this case, contains some covalent character. Now, what does this mean? Well, this means the forces holding the lattice together are stronger. Or we could have said, instead of silver iodide contains some covalent character, we could say silver iodide ions are not spherical. So silver iodide contains some covalent character, forces holding the lattice together are stronger. Identify a region that could be used to indicate the presence of iodide ions in aqueous solution. Describe observation made. Again, just how well you know your tests. And I think I need to go through this topic. I think it is a grade 1 topic. So, because when I first saw this question, I couldn't do it yesterday. So it's silver nitrite. And these questions just how well you know your mechanism. And yellow precipitate. Question 2.1 is a question about acidic solutions. Ka for acid dissociation constant, Ka for ethanoic acid given by expression. Ka is that at this at this temperature. A buffer solution of pH of that prepared using that. Buffer solution concentration of ethanoic ions was that. Calculate concentration of ethanoic acid. So first thing I would do is immediately rearrange the expression. Immediately. Because I know I need to find out the concentration of ethanoic acid, which is obviously going to be this. So immediately rearrange it, and I get this CH3 COO minus H plus divided by Ka. Okay. Now, do I know Ka? Yes, I do. 1.74 times by 10 to the power minus 5. Do I know concentration H plus ions? Yes, I can work that out by doing concentration H plus ions equals 10 to the power minus pH and therefore it's going to be 10 to the power of the pH, which is 3.87, 10 to the power minus 3.87. Concentration of ethanoate ions, it tells me already 0.136, and that's the concentration. I don't need to convert it, so it's going to be 0.136 times by 10 to the power minus 3.87 divided by 1.74 times by 10 to the power minus 5. 1.74 times by 10 to the power minus 5. I get 1.05, and it says to 3 significant figures, so that's perfectly fine. 1.05. The first time I did this question, I was like, this can't be that easy, but in reality, it is. It is. Probably, this is, I'm guessing how the marks are going. 1 mark for rearranging it, another mark for calculate concentration H plus ions, and then the third mark for your answer to 3 significant figures. Check the mark scheme, yeah. Get 1 mark for the H plus ions, and you know, if you just put it in a calculator, I don't think you can get the mark. I'm not sure. But always show your method, it is 3 marks. Part B, 2.2, in a different buffer solution, the concentration of ethanoic acid was that, and the concentration of ethanoic ions was that. A 7.00 times by 10 to the power minus 3 moles sample of sodium hydroxide was added to 500 centimeters cubed of this buffer solution. Calculate the pH of this buffer solution after the sodium hydroxide was added, and give your answer to 2 decimal places, 6 marks. Now, obviously, this is going to be a difficult question because it's 6 marks. However, that doesn't mean it's going to be necessarily anything you haven't learned. It just means there's going to be a lot of steps. That's what it means. So we need to work, use logical steps to find out the final answer. So I want to firstly find out the moles of ethanoic acid because I've got the concentration of ethanoic acid. I want to find out the moles of ethanoic acid. The moles of ethanoic acid. Well, it's going to be moles concentration 0.260 times by the volume. And I get 0.130 because the volume is 500 centimeters cubed. Obviously, we need to divide it by 1,000. That would give me 0.130 moles per dm minus cubed. Actually, no, 0.130 moles. Next step I need to do is find out the concentration of sodium ethanoate. How do I do that? Well, all I have to do in this case is 0.121 times by 500 divided by 1,000. So moles of the ethanoate ions. But remember that it's sodium ethanoate. So moles of sodium ethanoate Zero 0.121 times by 500 divided by 1,000. 0.0605. Third thing I need to do now I've got the moles of ethanoic acid, now I've got the moles of sodium ethanoate, and I know a 7.00 times by 10 to the power minus 3 sample of sodium hydroxide was added to the buffer solution. So what I need to do now is, well, firstly, let me construct the equation. HA plus OH minus A minus plus H2O. Now, obviously, with the water, we do not care about it. We don't care. Reason being is because if we look at the K expression, in this case here, there's no water. You don't need to find out the concentration of water, so we just basically ignore that. But it's still in the expression in this equation. So concentration of of H8 ethanoic acid 0.130. Concentration of sodium ethanoate ions 0.0605, and I know, so that's going to be here. And then I know sodium hydroxide solution 7 times by 10 to the power minus 3. 1, 2, 3. That should be 5. Now all I have to do is now I need to do 0.130, because obviously this one is smaller than this number. I'm going to do 0.130 minus 0.107, 0.123. This is how I like to express it out. And with these, 6 mark questions on this, it's best to take your time. That's obviously going to be 0. And because we subtract on this side, we're going to add on this side. So 0.0605 plus 0.007, 0.0675. Perfect. And now are we there now? Yes, we can quite easily now find out the answer we're looking for. So first thing I need to work out is, because I know I want the pH. So first thing I need to find out the concentration of H plus ions. And so I need to rearrange this expression to find out concentration H plus ions. So it's going to be concentration of H plus ions equals Ka times by concentration of CH3 COOH divided by CH3 COO minus. And does it give me Ka in the question? Yes, it does. 1.74 times by 10 to the power minus 5. So I'm just going to put it in my calculator now. It's going to be 1.74 times by 10 to the power minus 5 times by concentration of ethanoic acid, which is obviously that HA, divided by concentration of the A minus ion of the ethanoic ion, so 0.0675. That is the concentration of H plus ions. Now to find out the pH, well, pH equals minus log 10 of the concentration of H plus ions. So now I do substitute into there, so minus log 10 of my answer, and I get 4.498, so therefore the answer will be 4.50. Perfect. Question 3, the ionic product of water Kw is at 10 degrees Celsius. Which is the correct expression for Kw? Kw is obviously going to be concentration of H plus ions. Sorry, that times my concentration of H minus ions. So it's obviously going to be C. Calculate the pH of pure water at 10 degrees Celsius. Give your answer to 2 decimal places. Now this question is a tricky question because first thing you look at it, pH. So obviously I need the concentration of H plus ions. But it doesn't give me the concentration of OH minus ions, because if I wanted to find out the pH, obviously what would I do? H plus, concentration H plus is Kw divided by concentration OH minus. But a very, very important detail in the question, it tells me it's pure water. So we can assume concentration of H plus ions equals concentration OH minus ions. Therefore, Kw is not going to be concentration H plus times by concentration OH minus, it's going to be concentration H plus squared. Therefore concentration H plus equals square root of Kw squared. Kw is 2.93 times by 10 to the power minus 15. And then all I need to do now is substitute into pH. Well, pH equals minus log 10 of concentration H plus. Substitute into there. There's going to be square root of 2.93 by 10 to the power minus 15, substitute in pH, minus log 10 of my answer, and I should get 7.27. Okay, so just why does pure water at 10 degrees Celsius is not alkaline? It's not alkaline because the concentration of H plus ions equals the concentration of OH minus ions. So it's not going to be alkaline or acidic. That's all I have to say. or you could say equal moles of H plus ions and OH minus ions. 3.4. Calculate the pH of this much solution of calcium hydroxide at 10 degrees Celsius. So, Kw equals concentration H plus times by concentration OH minus, right? I want the pH, so I want to find the concentration H plus equals Kw divided by concentration OH minus. I know Kw because it tells me at 10 degrees Celsius, and at 10 degrees Celsius, Kw is at 2.93 times by 10 to the power minus 15. Don't just assume, which I did the first time I attempted this question, that Kw is 1.0 times by 10 to the power minus 14. That's at another temperature. If it tells you the Kw at a specific temperature, you have to obviously use that Kw value. Now the concentration OH minus ions, well, I've got this much of calcium hydroxide. Now you should know calcium hydroxide is that's the expression. So I've actually got 2 OH minus ions. So therefore what I have to do is I need to times this value by 2. It's going to be divided by 0.0131 times by 2, and then I have to find a pH. Well, pH is minus log 10 concentration H plus. So I just substitute that into here. So firstly, I worked that out. 2.92 times by 10 to the power minus 15 divided by 0.0131 times by 2. pH is minus log 10 of my answer, 12.95. And obviously with pH, always give to 2 decimal places, and it even asks us in the question to give to 2 decimal places. Question 3.5. The 0.013 moles 0.131 moles per meter cube solution of calcium hydroxide at 10 degrees was saturated solution. Student added this to this much of water, stir the mixture until no more solid dissolved. Predict whether the pH of the magnesium hydroxide solution formed at 10 degrees Celsius is larger than, smaller than, or the same as the pH of calcium hydroxide solution at 10 degrees Celsius. Explain your answer. Now the answer is going to be smaller. The pH of magnesium hydroxide compared to calcium hydroxide will be smaller, because if we use our knowledge of from year 1, we should know magnesium hydroxide is sparingly soluble. Or we can say solubility of hydroxides increases down group 2. So what does this mean? Sparingly soluble, or pH is minus log 10 of H plus, so it's not going to be the same amount of concentration H plus, and therefore not going to have the same pH. It's going to have a lower pH. Question 4. Sample of titanium is ionized by electron impact in a time of flight mass spectrometer. Information from the mass spectrum about the isotopes of titanium in the sample is shown in table 2. Calculate the relative atomic mass of titanium in the sample. Give your answer to 1 decimal place. So all it's going to be is 46 times by 9.1 plus 47 times by 7.8 plus 48 times by 74.6 plus 49 times by 8.5 divided by 100. And you should get 47.8, and just read the question properly, give your answer to 1 decimal place. Write an equation to show an atom of titanium is ionized by electron impact. So we just need to use your knowledge of electron impact equation. So we just go from here to that's it. The MZ value that will reach the detector first, so I'm looking for the one with the lowest MZ value, therefore it's going to be this one. So 46. Calculate the mass of 1 gram of 49 Ti titanium. So what I'd have to do first is I'd have to do 49 divided by 1000, because I want it in kilograms, and obviously this is going to be in grams. 49 divided by 1000 divided by 49 divided by 1000 divided by Avogadro's constant, 6.022 times by 10 to the power 23, 8.13 times by 10 to the power minus 26 in kilograms. Question 4.4, in the time of flight mass spectrometer, the time of flight of an ion is shown by the equation. In this equation, d is the length of the flight tube, m is a mass in kilogram of an ion, E is kinetic energy. In the spectrometer, the kinetic energy is that. Time of flight is that. Calculate time of flight 47 Ti plus ion. Okay, so what I would firstly do is, so I've got the kinetic energy, I've got the time of the 49 Ti plus ion. I want to find out the time of the 47 Ti plus ion. So first thing I'm going to have to do is, first thing I'm always going to have to do is, so I need to find out the distance of the flight tube. That's what I'm going to have to find, because yeah, there's no indication of it here. How would I do that? Well, first thing that I'm going to have to do is rearrange the equation, and that is probably going to be a tricky step. So it's going to be square both sides, I get d squared, I get, actually no, it's not going to be that tricky. Square both sides, I get d squared equals t squared times by 2e divided by m. And e is the kinetic energy of the ions. Okay, perfect. Now we need to find out the distance of 47 Ti. Well, I know the distance of the 47 Ti ions is going to be the same as the distance of the 49 Ti plus ions. It's going to be the same distance of the flight tube. So all I have to do really is distance of square root of the t squared, the time of flight 49 Ti plus ion, 9.816 times by 10 to the power minus 7 squared times by 2 times by kinetic energy 1.013 times by 10 to the power minus 13 divided by the mass of the 49 Ti plus ion. Well, it's just going to be 49 divided by 1000 divided by Avogadro's constant. This is going to be the square root of no, actually, all I do here is then I substitute my value, and so I got t squared 9.816 times by 16 times by 10 to the power minus 7 squared times by 2 times by 1.013 times by 10 to the power minus 13 divided by the mass of 49 Ti plus ion 49 divided by 1000 divided by 6.022 times by 10 to the power 23. And that's the distance squared, so I want to find the distance, so square root my answer. Okay, but I don't want the distance. I want time of flight of this ion. So then what I'm going to do is I'm going to do the distance times by square root of the mass of the 47 Ti plus ion, which I've already got. That's the 49 Ti plus ion. 40, well, it's going to be 47 divided by 1000 divided by 6.022 times by 10 to the power 23 divided by 2 times by 1.013 times by 10 to the power minus 13. I get 9.61 times by 10 to the power minus 7. Very complicated. Question 5. Titanium chloride, delta H starts. Calculate Gibbs free energy change. So first thing I'm going to do is I need to know the equation of Gibbs free energy change. Delta G is delta H minus G delta S. Okay, now it's going to be delta H, and it wants in kilojoules multiplied by minus 1. That is in kilojoules multiplied by minus 1. It's going to be minus 60 minus the temperature. Now I want the temperature in Kelvin, so I need to firstly convert that. So add 273, and I get 989 plus 273, 1262 Kelvin. So it's going to be minus 1262 times by delta S. Now, in order to find out delta S, well, it's going to be what? Delta S is entropy of products minus reactants. So it's just going to be products. I would write down the equation because the last thing you want to do is get confused in the equation, even if you know it off by heart, but you just better to write it down on paper. So the products, well, 2 carbon monoxide is going to be, well, this is delta entropy data, so it's going to be 2 times by 198 plus TiCl4 plus 253 minus entropy of reactants TiO2 50.2 plus 2 carbons 2 times by 5.70 plus 2Cl2 223 plus 223. So put that all in the calculator. 2 times by 198 plus 253 minus 50.2 plus 5.70 times by 2, 5.70 plus 5.70 plus 5.70 plus 223 plus 223. I get 141.4 positive value. Now, what is this measured in? Remember, entropy change always measured in joules. So it's going to be joules K to power minus 1 mol to power minus 1. But I want my final answer Gibbs free energy change in kilojoules, so I need to divide that by 1000. Now I put that in, and just that small mistake can cost me a lot of marks, not knowing my correct units. Times by 141.4 times by 10 to the power minus 3. Now I get so what is it? Minus 60 minus 1262 times by 141.43. I get minus 238 So you need to know your units. The first thing I would do always in chemistry is always memorize the units. Memorize the units until you know them, like you've gone through them so many times, because most of the time that's the main thing they're testing. How well can you rearrange the equation, and how well you know your units, and then obviously a bit more problem solving as well. But a lot of the time, those two things are very important as well. Then it says you should answer explain whether the reaction is feasible. Reaction is feasible. It is feasible. And obviously explanation why, because delta G is negative. Or we can say slash less than 0. Question 6. Write an equation for reaction of phosphorus with excess of oxygen. So phosphorus P4, oxygen O2. Now this equation you should memorize off by heart. Well, I think you have to memorize it off by heart, not should. And you should just recall it like this. P4 plus 5O2 are P4O10. Then it says, describe a test to distinguish sodium oxide product of reaction in question 6.1, so phosphorus oxide. Now this one is a bit trickier, but the idea is we want to add water. Bit more tricky. Add water, add litmus paper, add litmus paper, and litmus is blue with sodium oxide, blue with sodium oxide, and red with phosphorus oxide. Now I can't particularly remember this in pair 3 elements and oxide, this test. So what I'm going to do now is I'm just going to quickly go through the textbook and see where it exactly is. So my year 2 textbook, obviously, because this is a year 2 topic. And can't really see it. I'll have a look in this for my teacher or something later on. State the type of crystal structure shown in silicon dioxide and sulfur trioxide. Silicon dioxide, giant covalent, and sulfur trioxide is probably going to be a bit more harder. It's just molecular, or even if you say simple molecule, that's fine. Question 6.4, a nice 4 marker. The reason I say nice 4 marker is because it is a nice 4 marker. It just wants you to talk. So it's very specific, obviously. So first thing I would say, silicon dioxide has covalent bonds between atoms. However, van der Waals forces between molecules in sulfur trioxide, and then I'd say obviously covalent bonds are stronger than van der Waals forces, as covalent bonds take more energy to overcome. That's it. Talk about the bonds in that. Talk about why these bonds are stronger than that. Just state a simple sentence: covalent bonds are stronger than van der Waals forces, and then why does it have a higher melting point? Because it takes more energy to overcome. Write an equation for the reaction of sulfur trioxide SO3 plus potassium hydroxide, KHSO4. One equation for reaction excess of magnesium oxide, 3MgO plus H3PO4 arrow Mg3PO4 2 plus 3H2O. Question 6.7, draw displayed formula of undissociated acid formed by sulfur dioxide reacts with water. You got the S, the double and O, OH, and it reacts with water. It's just going to have this lone pair of electrons with these two, so that's it. Question 7, I can't go through that because I haven't gone through this topic yet. Question 8, describe a simple test. Describe how a student could distinguish between aqueous solutions, potassium nitrate and potassium sulfate. Now, first thing I would notice is that sulfate ions, so I'm going to use barium chloride. If I use barium chloride, potassium sulfate ions, what I'm going to get is I'm going to get white precipitate. And therefore, with potassium nitrate, I'm just going to get no reaction, or no visible reaction. That's it. 8.2, describe a student could distinguish between aqueous solution, magnesium chloride, aluminium chloride using one simple test tube reaction. So, say any group 1 hydroxides, in this case sodium hydroxide, with magnesium chloride, white precipitate. With aluminium chloride, it is also white precipitate, however, which dissolves in excess sodium hydroxide, NaOH. Question 9, several stages in industrial production of methanol from methane. Reduced optimal conditions for the industrial conversion. 6 marks. You just need to. This question is about how well can you interpret information with these kind of graphs, and obviously just basic knowledge that you should know. So stage 1, the deductions from graphs. So I can already see that the yield increases as temperature increases, and I can also see that after a certain temperature, yield no longer increases. And I can also see in the other graph, percentage of conversion methane at constant pressure, well, yield decreases as temperature pressure increases. Yield decreases as pressure increases. It's just these simple statements. What can I see here? Well, as I increase the temperature, what happens to the yield? It increases, but then at a certain temperature, here, the yield no longer increases, and in this one, as pressure increases, the yield just keeps decreasing. Just simple statements, nothing too complicated. Stage 2 now, the optimum temperature, and obviously my explanation. So if I look at the graph again, I can quite clearly see the optimum temperatures around about 800 to 850 or 8. You don't have to be exact, you just need to be like not too far off. So I would say, first thing first, high temperature results in high energy cost. After a certain temperature, yield no longer increases, what I just stated before. And what that means is therefore no gain in using a higher temperature. And then I say optimum temperature is 800 degrees Celsius. Stage 3, optimum pressure. Well, I know actually, no, because I want low pressure. Because low pressure gives me the highest yield. But what I need to say is that low pressure is too slow. It takes too long. So compromise pressure is required. So optimum pressure is, I'd say, 2000 kilopascals. So the idea of compromise as well in this question. And in question 9.2, equation shows the final stage of production of methanol. Calculate the amount of moles of carbon monoxide of hydrogen in the equilibrium mixture. So first thing I would do is I just use this method. Hopefully you guys, if you would find it useful. If you don't, just use your method. Carbon monoxide, hydrogen, and I've also got methanol. Obviously I should be straight lines just like that. So I know initially I've got 20.1 moles of carbon monoxide, and initially I've also got 24.2 moles of hydrogen. And then I know equilibrium established at 600 Kelvin. Equilibrium mixture contained this much of methanol, so I've got 2.16 moles of methanol. So initially of methanol I've got 0, so I've added 2.16. Therefore I'm going to minus 2.16 on the left hand side. So if I'm adding something here, I'm going to be minusing it here. Minus 2.16. But this case, hydrogen has got 2 moles, so I'm going to minus 2.16 times by 2. Now, all I do is just put that in a calculator. Minus 2.16, 17.94 carbon monoxide. And for this one, hydrogen, minus 2.16 times by 2, 19.88. Question 9.3, and then I can't do, I'm not going to do question 10 because I haven't gone through that topic. I can do 10.1, and maybe I will. But anyway, question 9.3. A different mixture of carbon monoxide and hydrogen allowed to reach equilibrium. An equilibrium mixture contained this much moles of carbon monoxide, this much moles of hydrogen, this much moles of methanol. The total pressure was this. Calculate value for equilibrium constant Kp for this reaction and state its units. Now, a lot of students, including myself, would see 6 marks and, be very intimidated. But in reality, it's think about it. So 1 mark for the units, 1 mark for the answer. So minus 2 marks, that's 4 marks. So 4 marks for my method basically. And those 4 marks are going to come from finding out, in this case, mole fraction, partial pressures, substitute into my Kp expression. Yeah, it's not going to be too complicated. So first thing I need to do is work out the total number of E moles, which is equilibrium moles. I'll just write it down fully. So all I have to do is 2.76 plus 4.51 plus 0.360. That will give me 2.76 plus 4.51 plus 0.360, 7.63. Now what I need to do is find out the mole fraction. So I've got carbon monoxide, I've got hydrogen, I've got methanol. Now what I would do is carry on with this table, add an M and a P, but these moles are different, and these equilibrium moles are different to this one, so I'd have to do it all over again starting from E. I don't want to do that in this case. So I'm going to do carbon monoxide 2.76 divided by 7.63. and I can already do that because these are the equilibrium moles. So yes, they've given me that already, so that's really nice. Methanol 0.360 divided by 7.63. Now I want to construct the Kp expression. Well, Kp, obviously, Kp is going to be, remember, it's going to be curly brackets. So it's going to be the partial pressure of my products over reactants. Now I know I'm producing methanol, so the partial pressure of methanol, CH3OH, divided by the partial pressure of carbon monoxide times by the partial pressure of hydrogen squared, as I've got 2 moles of hydrogen. Again, that 2 moles. So now the partial pressures, I need to do the mole fractions times by total pressure 630 kilopascal. So that's what I'm going to do now. I'm just going to create my calculator. So it's going to be 0.360 divided by 7.63 times by 630 divided by 2.76 divided by 7.63 times by 630 times by 4.51 divided by 7.63 times by 630, and that's obviously squared. I get Kp as 9.41 times by 10 to the power minus 7. And I used it with kilopascals because it doesn't tell us what units it wants. It wants us to state the unit. So I could have converted into pascals and times it in pascals, but I don't want to do that. I wanted to use kilopascal. So therefore my answer is 9.4 times by 10 to the power minus 7. 9.41 times by 10 to the power minus 7. Now the units, because I was using kilopascals, that's going to be kilopascals divided by kilopascals divided by kilopascals times by kilopascals squared, which is the same as kilopascals divided by kilopascals cubed, which is the same as 1 over kilopascals squared, which is the same as kilopascals power minus 2. And that's it. Question 10. Now I will do the first part because I know how to do it. Oxygen to nitrogen, well, oxygen minus 2, chromatography minus 6, overcharge minus 1, therefore that's going to be plus 5. And in this case, that oxygen is always going to be minus 2, so that's going to be plus 2 in this case. I can't go through the rest of the questions because I don't know how to do it. I haven't gone through in class. Question 11 is a question about compound containing ethane dioic ions, white solid mixture. I can't do question 11.2, I haven't gone through that. I can't do question 11.3. I think I can do question 1.4. So question 11.1, 8 marks. So I need to zoom out for this question. White solid is made a mixture of sodium ethanoate dioate, ethane dioate, ethane dioic acid, dihydrate. In this first titration, titrated this much solution of potassium mangate. When this much added, solution change color. So what I would do here is I've actually got enough to find out the moles of the mangate ions, the MnO4 minus ions, which is just going to be the concentration 200 times by 26.50 divided by 1000, which is 5.30 times by 10 to the power minus 4. That's nice. Now what I want to do is, well, obviously I want to find percentage by mass of sodium ethane dioate, the white solid. I want to find out the moles of this. So I'm just going to times that by 2 over 5. No, sorry, I'm going to times it by 5 over 2. Or aka divide by 2 times by 5. and I get 1.325 times by 10 to the power minus 3, and that is for the Cr2042 minus signs. That's the moles of that. Now what I can do, now I've got the moles of that, I also know 25 centimeters can titrate with this much of sodium hydroxide, indicate change colour after this. I can work out the moles of sodium hydroxide. Which is just going to be 10.45 divided by 1000 times by 0.100, which is 1.045 times by 10 to the power minus 3. Now that I've done that and that, now I've got the moles of sodium hydroxide, I can find out the moles of this. I just divide by 2. So the moles of that is just going to be that divided by 2, which is going to be 5.225 times by 10 to the power minus 4. Fifth step now. Now I've got the moles of that. What can I do? What can I do? I've got that moles of that from the acid. So what I can do is I can do initially the moles of that, which I got 1.325 times by 10 to the power minus 3, minus this, and that will give me this sodium ethane diode in the white solid. So what I'm going to do is I'm going to do 1.325 times by 10 to the power minus 3 minus 5.225 times by 10 to the power minus 4, 8.025 times by 10 to the power minus 4, and that's obviously in 25 centimeters cubed, because that's what I've been using the whole time, 25 centimeters cubed, 25 centimeters cubed. But I know it contains this much in 250 centimeters cubed. So now what I need to do is times that by 10. And if I times that by 10, all I get is 8.025 times by 10 to the power minus 3. Now that I've got that, now I can work out the mass of sodium ethane diode. So the mass is just going to be the moles, 8.025 times by 10 to the power minus 3 times by the MR, which you use the periodic table, and you get as 134. That will give me 1.075 grams. And I know that is this mass and the white solid, and I know initially I've got this much mass solid. So therefore, for the final step, what I'm going to do is 1.075 divided by 1.90 times by 100, because I want it as a percentage, and I get, where should I put my answer? 56.6%. Does it ask it for 3 significant figures? Appropriate number of significant figures, so give it 3 significant figures. Very difficult question. But really, I would, if I don't even have a highlighter in the exam, I'd put my hand up for a highlighter if I was in the exam doing this question. Highlight. No, I'm not going to highlight every single part. I'm going to highlight, the concentrations, the volumes that I can possibly use to even find out some moles, and then use a molar ratio. So start off with just working out moles, and then I can, build upon that. But yeah, very difficult question. 8 marks. 11.2 can't do. 11.3 can't do. 11.4. It says ethane dioic ions are poisonous because they react with ions in the body. Ethane dioic ions are present in foods such as broccoli and spinach. Suggests one reason why people who eat these foods do not suffer from poisoning. More of a definitely application question, like apply it to, in this case, reacting with ions in the body. But the idea is that the ethane, actually I'll just say low concentration ethane dioic acid is only present in small quantities, aka low concentration in these foods. And it makes sense. why do they not suffer from poisoning? Because it's in extremely low concentrations. Therefore, it's not going to be harmful to the human body. And that is the end of the paper.